This particular question is asking us to find the chain rule. So we can see this funky function Q is A on the outside at -1 and B on the inside at -1. So normally our function on the outside would be this slope, and it's a bit weird because we don't have an equation for it. So I'll write us an equation to say that A of t at this point is equal to our gradient, which is -1, because we can see every time we move across by 1, we drop by 1. So m is equal to our rise divided by our run, okay? And that is equal to -1. So it's minus x. And then we can see that the plus bit is going to be this point here, our y-intercept, which is going to be at 6. And again, you don't have to write the equation here. I'm just doing it so you can see the equation. Otherwise, it gets kind of confusing. So this guy, he drops by quite a lot, actually. So we run along 1, but we drop by 2. So it's minus 2x. And we cross here at -1. So what this is saying is we've got this function a, normally like this, right? A at t. Apologies, I've been using x, and that should be using t. So let me change that quickly. So we got a at t, and that's just this like minus t plus 6. Okay, but now what we're going to do is whenever we see this value, we're going to stick in this big thing here. Okay, so let's do that. So it's now equal to minus, and then we've got that 2t minus 1 plus 6. So now this is what our function q of t is equal to. And that's what it means by that. So we have to use a chain rule. And when we use the chain rule and we differentiate q, we get it as the stuff on the outside differentiated, right, times by the guts of it differentiated. So hopefully you can see that's the inside bit and that this is the outside bit. So what we're going to have to do is find b prime t, all right, but at this point -1. So we don't have our equations here, so assume we don't have any of our equations. Now we just got to look at it graphically, okay? And to do that at -1, which I guess pretty simple, we just find the gradient. So we've just found it here. The rise on the run of this one is -2. So what we can say is that our b prime t is equal to -2. Now, if you notice, we're going to need to find b t because we substitute that into a. So that is this guy here. All right. And that is all at point -1. And so when we do that, for b at -1, the actual value is going to be 1. So skirting along here, this value here is -1 and 1. So our answer for that bit is 1. Now the next bit we need to find is a prime of 1. That's the value that we found from here. That goes into there. All right, so that's why that value 1 goes here. So a prime of 1 now gets us to go here. And we're trying to find the gradient here, not the value, but the gradient, because it's the prime. All right, and we see that that is -1, okay, because we run along by 1 and we drop by 1. So our m, which is equal to our rise over our run, is equal to run along by 1, drop by 1, -1. Okay, so we put that in there, get -1. And that is our final answer. So we kind of grab this bit in blue, right? And we stick him back in the equation. And now we grab this bit in green and we stick him back into the equation. And we are done. So this is our final equation. All right. This is difficult, not gonna lie. It's pretty confusing, right? It's like you find one value, B of 1, and have to stick it back into it. That's kind of weird. So I'd recommend refreshing the web page multiple times and attempting this over and over again, and you'd see the pattern emerge. It's a pretty unique question, but it really shows you how the chain rule is used, especially when you don't have functions and numbers and letters to go with it. So just something different. Hope that helped.